So today we are going to see a presentation on ocean thermal energy conversion. So as we all know, there is difference of temperature between a top surface of the ocean to the bottom surface. The top surface of the ocean water will be hotter as compared to bottom surface. So ocean thermal energy conversion uses this principle and principle of heat exchanger to convert the temperature gradient of ocean surface into thermal energy. Now I will share the presentation. Ocean thermal energy conversion. So using temperature gradient, that is difference of temperature between a warm top surface and bottom surface. That is, warm surface will be at a higher temperature, which is T1, and bottommost part will be at a lower temperature T2. So this T1 minus T2 is the temperature gradient. So it should be minimum 20-degree difference. There should be a minimum of 20-degree Celsius difference in order to establish a ocean thermal energy conversion power plant. So the ocean thermal energy cycle generates electricity using temperature difference between surfaces of an ocean. So it is based on a Rankine cycle, which consists of a boiler, a turbine, condenser, and a pump. So a warm water vaporizes a fluid. How it vaporizes? The warm water will vaporize the fluid, right? So it will vaporize using heat from hot water from the top surface of the ocean. Hot water from the top surface of the ocean. So warm water will vaporize low boiling fluid and produce steam. The steam will be sent to the turbine to generate electricity, and cold water condenses vapor back to liquid. So for condensing the cold water, the bottom surface water, which will be cooler, will be employed to convert the vapor back to liquid in the condenser. So this is a schematic diagram where hot water from top ocean surface is used as a heat exchanger for evaporator to evaporate the working fluid and produce steam. And the steam is sent to the turbine where mechanical energy is produced, and remaining steam is sent to the condenser where the cold water from deep sea is utilized to convert steam into again liquid, and again the cycle continues. So in this particular drawing, ammonia is the working fluid. So this is a closed cycle OTEC, that is closed cycle ocean thermal energy conversion. And in other words, there is another type which is called open cycle, where seawater itself will be working fluid. Hot water from the top surface will be evaporated, and again cold water from the bottom surface will be used for condensing the steam. So that is open cycle, where seawater itself is used as the working fluid. Closed cycle will use ammonia or similar working fluid other than seawater. Seawater is used only as heat transfer medium in the closed cycle. Hybrid power cycles combines both the system, both open and closed cycles. System components: intake pipes for the transport of seawater, and heat exchangers for transferring heat to evaporator and absorbing heat from the condenser, and turbine for generating mechanical energy, and condenser for converting the working fluid, that is liquid, to again vapor to again liquid, and pump is for increasing the pressure of the liquid. So this is open OTEC, where warm surface water is directly injected into evaporator, where it is converted to steam, and steam is sent to the turbine and mechanical energy is produced, and cold surface water is used for condensing the steam produced from the evaporator. Closed cycle you have already seen, as with ammonia as the working fluid. So how we will select site for establishing a ocean thermal energy conversion plant? So the tropical ocean regions with high thermal gradient, that is the difference of temperature between top surface and bottom surface should be high. It should be at least 20 degrees Celsius to achieve required electricity. And as high as the gradient, the capacity of the plant will be more. And proximity to deep ocean, the depth of the ocean should be as minimal as possible, and stable marine conditions, and it should be accessible to the power grid. So advantages is renewable and sustainable, as seawater is a renewable source of energy and base load power. So the power can be produced when there is 20 degrees Celsius temperature difference between top surface and bottom surface, and it produces fresh water. As the seawater is evaporated, it will desalinate the seawater and it is used for producing fresh water. And it supports aquaculture, where the fresh water are sent to the estuaries or rivers, streams nearby to nurture aquaculture, and reduces fossil fuel usage. That is, fuels from which produce carbon or nitrogen based emissions. So those fuel usage shall be reduced. Challenges: high capital cost. To establish, we need a lot of equipments. So the capital cost is high and efficiency is lower. So that is, we have to give power to run the pump. So the efficiency will be around 3 to 5%, and there is a chance of corrosion and biofouling as salt water is involved. So applications: electricity generation, freshwater production, that is desalination of seawater, aquaculture, and the production of estuaries, air conditioning, and mineral extraction. So there are projects which are going on in Hawaii, India, Japan, France, and Korea. The focus will be on improving the efficiency and scalability. So small scale projects are established now. So the focus is now on increasing the capacity of established plants. So we will see another case study on this open thermal energy conversion later. Thank you.